welcome to your 6th video. So in video 6, what we're going to be talking about is scientific notation. Our objective is to write numbers in standard form and write numbers in scientific notation. So today you guys are going to learn what standard form is, and you're going to learn what scientific notation is, and hopefully you guys will be able to do that. The standard we're going to be addressing is 8th grade equivalent expression standard number 4. Let's go ahead and copy our vocab and let's start this lesson. For our vocab today, we only have one vocab word, scientific notation. The definition of scientific notation states that when a number is written as a factor and an integer, power of 10, the factor must be greater than or equal to 1, but less than 10. So what's happening is, if you're going to rewrite a number like this number here, 425 million, what we'd have to do is we'd have to make this number a number between 1 and 10. It has to be either greater than or equal to 1, and it has to be less than 10. Well, if we look, this is 4.25. That's greater than 1, and less than 10, that's the correct number. Now, when it says an integer power of 10, we're going to multiply by 10 to some power. Now, an easy way to figure out what power it is, look at this number and say, okay, well, where do I want my decimal? Okay, well, I want my decimal to be between the 4 and the 2. Because what's happening is we have to make this number go between 1 and 10. So what we do is we count 1, 2, 3, 4, 5, 6, 7, 8. That means that we really want our decimal to move 8 times. So when we multiply by 10, that's telling us we're moving the decimal. And since it's an 8, that means we're moving the decimal 8 times to recreate this number. This is called standard form whenever you just write the actual expanded decimal out, or number out. And this is called scientific notation, when you write a number that looks really big, a lot smaller. Scientific notation is a great way to take big numbers and write them small, or really, really small numbers, and write them so that they're easier to read. So one of the things we're going to do in the very first few examples is we're going to take a number that's written in scientific notation, and we're going to change it to standard form. Standard form is a common way that we see a number. So when we see a number that's written really large or really, really small without any times 10 to some power, then that's probably written in standard form. If we're changing from scientific to standard form, we need to look at the exponent where it says times 10 to some power. If that power is a positive number, what we're going to do is we're going to take that decimal and we're going to move it to the right, whatever the number is on that exponent. And if that power is a negative exponent, we're actually going to take that decimal and we're going to move it to the left, whatever the number is for that exponent. So we're going to go ahead and practice this so this will make a little bit of sense for you. And hopefully you guys understand this as I talk about, well, if it's positive, we move to the right, negative, we move to the left. We're going to go ahead and practice this and see what happens. So in example 1, what we have here is we have a problem. It's written in scientific notation. Our job is to write it in standard form. Again, standard form just means how we normally see that number. So again, this problem is written in scientific notation. And it's scientific notation because we have a number between 1 and 10. This is 5.34 times 10 to the 4th power. We're going to change this back to its regular number. So what you do is you write the number you see, 5.34. So I have my decimal, 5.34. Make sure you look at the exponent. The exponent is a positive 4. Now on the previous slide, what I talked about was I said that if we have a positive exponent, then we're going to move the decimal to the right as many times as we see this number here. So what we would do is we take our pen, put it right there on the decimal, and we're going to move it 1, 2, 3, 4. So our decimal is actually going to be all the way over here now. And since these have nothing in between them, what we have to do is we have to fill those voids. We're going to actually fill those with a 0. So now, reminder, the decimal is no longer here, it's now all the way over here. So the number we get when we take 5.43 or 5 3400 times 10 to the 4th power, we're actually getting 53,400 and the decimals all the way at the end here. So to change a number from scientific to standard, we look at the exponent and we decide if we move the decimal to the right or we move the decimal to the left. If we move it to the right, the exponent had to be a positive. If we move it to the left, the exponent had to be a negative. And we move it however many times the exponent tells us to move it. Let's go ahead and do another problem. In example 2, we're kind of doing the same thing. We're starting with 9 and 6200ths, or 9.62 times 10 to the 5th power. Again, we have a number written in scientific notation because this number in front is between 1 and 10. Writing in scientific notation, number in front has to be between 1 and 10. So we're going to change this to standard form. Again, that's normally how we would see the number. So we're going to change it back to what it would normally look like. Start with your decimal, 9.62. Look at your exponent. My exponent is a positive 5. A positive 5, again, tells me to move that exponent 5 times. And since it's a positive, I'm going to move it to the right. If it was a negative, I'd move it to the left. So we're going to move this decimal 5 times to the right. 1, 2, 3, 4, 5. So now the decimal is going to be all the way over there. And so I'm going to kind of erase this decimal here. And again, in these little divots that we have, we're going to put zeros in those places. So if I rewrite this number, I have 962,000, which means that this number is 962,000. That's the number that we would get if we were to write it in standard notation. So this is standard notation where it's all written out. This is scientific notation where it's a number that has a decimal times 10 to some power. In this decimal, what we're going to do is we're going to take this scientific notation number and we're going to write it as its decimal. In this problem, we're going to take this scientific notation number and we're going to write it as its decimal expansion. So we have 3.27. So again, we're going to start by writing that decimal, 3.27. Go back and look at your exponent in this one. This one says times 10 to the negative 3rd power. Since that's a negative number, we're not moving the decimal to the right. We're actually going to move the decimal to the left. So we put our marker on the decimal, and we're going to move to the left however many times the exponent tells us. Well, the exponent tells us to move to the left 1, 2, 3 times. So here's our decimal all the way in the front now. Again, we move to the left because it's a negative exponent. Move to the left on a negative exponent, move to the right on a positive exponent. These spots are filled in with zeros. So we're going to rewrite the number, not showing these little marks here. So the number written in scientific notation is 0.00327. So writing a number in standard form is a lot easier to do whenever you just know which way you're moving your decimal. A negative moves it to the left, and a positive moves it to the right. Let's try one more problem like this. So in our last problem that we're going to be changing the standard form, example 4, we're taking 2 and 8500ths times 10 to the negative 5th power, and we're going to change that to standard form. Write it like it's normally supposed to be written. Again, the exponent's going to tell me if I move left or right, and this number is what we're going to start with. So we go ahead and we start with writing that number down, 2.85. Now that exponent's negative. A negative means I'm moving to the left. So I'm going to take this decimal, and I'm going to move it to the left 1, 2, 3, 4, 5 times. So each time you move it, count it. One time, it's in front of the 2, 2, 3, 4, 5. And if you have empty spaces, you're allowed to fill those in with zeros. So this decimal is actually 0.00285. So in standard form, this is scientific notation, this is standard form. In standard form, we have the number actually expanded out. In scientific notation, this number became a number between 1 and 10. 2.85 is bigger than 1, but less than 10. So they had to move the decimal. So now we're going to learn how to change it from standard form back to scientific notation form. So make sure you copy down the next slide, which kind of goes over it a little bit, but we're actually just going to practice that and kind of get the feel of how to do it. So let's keep moving. One of the things we have to understand about scientific notation is when we're making that number between 1 and 10 based off the rule, we have to have a number between 1 and 10. What we're going to be doing is we're going to place a decimal at the end of the problem if there isn't a decimal. And we're going to decide if we have to move the decimal to the left, then the exponent is going to go up that many times based on how many times we move it. And if we have to move the decimal to the right, then the exponent is going to go down that many times. So I'm going to actually write this as a rule as we practice changing a few numbers to scientific notation. So go ahead and make sure you have this down. I'm going to explain this using this rule as we write numbers in scientific notation today. Alright, so we're moving on to our next type of example. So in this example, we're taking a number that's written in standard form and we're going to write it in scientific notation form. So you guys just copy down. We're going to put a decimal at the very end of this problem if no decimal exists. If decimal exists, you don't have to put a decimal anywhere, it's already there. So there's no decimal in this problem, we're always going to put a decimal at the very end. That's where our decimal's at. Our job is, though, that we have to write this as a number between 1 and 10. So this decimal is going to have to move somewhere inside this number so we can make it a number between 1 and 10. So we need to figure out where can I put a decimal and make it between 1 and 10. If I put the decimal here, is it going to make it between 1 and 10? Here, 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 here. There's a couple different spots I can put it. If I put it all the way in the front, is it going to make it between 1 and 10? And it wouldn't. If I put it all the way in the front, it would be 0.3725. So I don't want to put the decimal there. What I want to do is I want to put the decimal somewhere that's going to make this a number between 1 and 10. This decimal is going to go all the way right here. So it's now going to say 3.72500. So what I did was I moved the decimal all the way from the back to the front. Now you copy down the directions of scientific notation. If we move the decimal to the left, the exponent's going to go up. So the exponent number that we're using is going to be going up. So we count up. This is a positive 1, 2, 3, 4, 5, 6. So what we would do is we would write that this is 3.725. Now, since there's these zeros here and there's nothing behind them, we could actually drop off those numbers. We can stop right here, and we can write that as times 10, because we have to use the base of 10 when writing a number in scientific notation. And the number of times we move the decimal is going to be our exponent. So since we moved the decimal to the left, the exponent number is going to go up 1, 2, 3, 4, 5, 6 times. So this is 3.725. 0.75 to the 6th power. And again, if we're writing this in scientific notation, our standard notation, since this is a 6, we would move the decimal 6 times to the right to get back to our regular number. So to go from standard notation to scientific, we're actually going to make the exponent go up. To go from scientific to standard, we'd make the exponent go back down. So in here, we look at the exponent, that's 6 times. That means we'd move it 6 times, and we should get the number we started with. So depending on how many times you move the number, that's what your exponent's going to be. Now here's a little hint. If you have a whole number to start, your exponent's going to be positive. If you have a decimal to start, your exponent should be negative. Let's try another problem. In this example, we're changing it to scientific notation. Again, it's written in standard form. Standard form is how we normally see a number where it's not times 10 to some power. So I'm looking at this number. I don't see a decimal, so our job is to put a decimal at the very end. Now, we have to move that decimal so we can make this number a number between 1 and 10. So think about where you could move it so that way it's between 1 and 10. Well, I see the number 9 here, and so if I put the decimal right behind 9, I now have 9.315. That's between 1 and 10. It's less than 10, but more than 1. So I'm going to write 9.315. Reminder, I don't need all these extra zeros. I just need the numbers. Unless there's like a 0 and then a number, then I need to include those. But anything that has just zeros at the end, you can drop off all those zeros at the end. Then you're going to write times 10. And now you just have to have the ability to count. We moved it 1, 2, 3, 4, 5, 6, 7, 8 times. So this would be 9.315, or 9 and 315 thousandths, that times 10 to the 8th power. So again, we count how many times we moved it. Since it was a whole number, I know my exponent's going to be positive. If it was a decimal, my exponent would probably have been negative. Also, we moved the decimal to the left, which means our exponent should be going up. If we had to move the decimal to the right, the exponent number should be going down. Let's try another one. This time, let's do one with decimals. So scientific notation is a way of taking really big numbers and making them a little bit smaller and easier to work with. We also take really small numbers like this decimal here, and I'm going to make this decimal just a little bit nicer so we can see that. And so scientific notation allows us to take a really small number like this decimal here and write it a little bit nicer and easier to read. So again, we have a number that has a decimal. The decimal's already there, so we don't need to put a decimal in. It's already there. We only put a decimal in if a decimal's not there, and we put it at the end of the problem. Since there's a decimal in this problem, all we got to do is write this as a number between 1 and 10. So think about this. If I move the decimal to the left, is it going to make it between 1 and 10? The answer is no. So what we need to do is we need to move this decimal to the right this time instead to the left and make it somewhere between 1 and 10. Now, if I move this decimal all the way to the end, I would have 316. Well, that's too big. 316 is way bigger than 10. So if I move this decimal between the 1 and the 6, I'd have 31.6. Still bigger than 10. So we would actually have to move this decimal between the 3 and the 1. So our decimal is going to go right here. Right in between the 3 and the 6. So I'm going to go ahead and put the decimal there. So I know it's going to go 1, 2, 3, 4 spots. So the decimal moved 4 times to get to that number. Now I'm going to write this decimal, everything from this way to the right. It's 3.16 times 10. So I have this number that's at the end, the numbers, not the zeros, but these numbers right here. 3.16. Is that between 1 and 10? Yeah. So, since this is between 1 and 10, we're good on that. Now we have to figure out what exponent are we going to use with our 10. Well, we move the exponent to the right. And we said earlier that if we move the decimal to the right, we said earlier if we move the decimal to the right, the exponent's actually going to go down. So we start with 0. This is -1, -2, -3, -4. So, this would be our decimal expansion of this problem. 3.16 times 10 to the negative fourth power. So in this example, we're working on another decimal. This is 44 10,000ths, or 0.0044. And we have to write this number in scientific notation. So that means like times 10 to some exponent. So again, we have to move the decimal somewhere this way, so that way it makes the number between 1 and 10. Well, I know if I put it behind the 4s, I'd have 44. So I don't want to put it behind the 4s because I know that 44 is more than 10. I'm going to put it in between the two 4s, 4.4. 4.4 is bigger than 1, but less than 10, so that's good to go. So we're going to write that number, 4.4. Again, you don't need to include the zeros that are in front. Now what you have to do is say, how many times did I move the decimal? Well, it's easy. I count 1, 2, 3 times. So we move the decimal 3 times. So it's times 10. Now again, since it's a decimal and we moved it to the right, that means the exponent is actually going down. We start with 0 as our number. We go down 1, that's negative 1, negative 2, negative 3. So in scientific notation, this number would be written as 4.4 times 10 to the negative third power. The best thing about scientific notation is now that we have some number to an exponent of 10, or a power of 10, it's going to make it a lot easier to add, subtract, multiply, and divide, which is what we're going to be doing in the next lesson. So it's important to be able to change it to scientific notation because it makes those skills a little bit easier to work with as we solve problems. In this example, we're going to look at something that could be related to real-life examples. Rather than using really big, large amounts of money, we're going to compare the dollars spent by visitors in the United States from 4 different countries: Canada, India, Mexico, and the United Kingdom. So it says refer to the table at the right. So we have that table at the right. Order the countries according to the amount of money that visitors spent in the United States from greatest to least. So what we're going to do is we're going to look at these numbers and we're going to establish which one is the biggest number based on the fact that they're in scientific notation. So looking at Canada, they were 1.03 times 10 to the 7th power. India is 1.83 times 10 to the 6th power. Mexico is 7.15 times 10 to the 6th power, and the United Kingdom is 1.06 times 10 to the 7th power. So what we have to do is we have to look at those numbers and say, what's the biggest one? And we can easily establish which one is the biggest based on the exponent that goes with the decimal. Because all of these are between 1 and 10, we're now going to look at the exponent to say which one is the biggest. Now, remember, the exponent tells us how many times we've moved that decimal. The more times we move that decimal, chances are the bigger the number is going to be. So looking at this, the United Kingdom had 1.06 times 10 to the 7th, and Canada had 1.03 times 10 to the 7th. So looking between those two, because they're both 10 to the 7th power, the UK 1.06 is bigger than 1.03. So what we would do is we'd say that it goes to UK, which is 1.06 times 10 to the 7th power. The next one would have to be Canada, and that's because it's 1.03 times 10 to the 7th power. So right now, what I have is I have the UK, 1.06 times 10 to the 7th. The next one would be Canada, 1.03 times 10 to the 7th. And now we're going to look between India and Mexico. India was 1.83 times 10 to the 6th power. That's how I knew it wasn't the biggest. And Mexico is 7.15 times 10 to the 6th. Since those are both times 10 to the 6th power, I knew they weren't the biggest. I now need to establish which one's bigger between the two of those. Well, 1.83, 7.15, 7.15 is bigger than 1.83, and they both have the same exponent. So that means that Mexico would be the next highest spending country. And that is 7.15 times 10 to the 6th power, which means that our final country would be India, and they are 1.83 times 10 to the 6th power. So when looking at these, we can actually establish which one is the highest amount based on the exponent, because they're all numbers between 1 and 10, so that makes them easier to look at. And then the exponent tells us which one is the highest if it has the highest number in front and the higher exponent. So this is a way that we can use scientific notation to order numbers from greatest to smallest. Let's try another example, and then you guys should be done for today. In example 10, your very last example, what we're going to do is we're going to compare frequency of colors and how much visible light is shown in the spectrum. So we have the colors blue, green, orange, and red, and violet. So we have to look at those and we have to say which one is the greatest to which one has the least frequency of maximum light on the spectrum. So on this, we're looking at those numbers. They're all 10 to the 14th power. Since they're all 10 to the 14th power, all we got to do is look at the decimal to establish which one is the biggest between them. Reminder, the decimal should all be between 1 and 10 because that's what scientific notation is. So we have 6.7, 6.1, 5.1, 3.8, 7.5. 7.5 is bigger than all the others, so that means that violet is the greatest. So I put the word violet up here, and that's because it's 7.5 times 10 to the 14th. The next one, since violet's gone, we have 6.7, 6.1, 5.1, 3.8. 6.7 is the biggest, so blue would be after violet. And that's 6.7 times 10 to the 14th power. After blue, we get 6.1, 5.1, 3.8, 6.1. So green would be your next. And then after green, you have 5.1 and 3.8. 5.1, which is orange, which is 5.1 times 10 to the 14th. And then finally, your last one would have to be red, which is 3.8 times 10 to the 14th. So again, writing numbers in scientific notation makes it a lot easier to see which one's bigger, which one's smaller. Because if you were to write these in standard form, they'd look like really, really big numbers. Because every one of these would have to move the decimal 14 times. Then you have to compare those numbers and see which one is bigger or smaller. So scientific notation will make it a lot easier to look at a really big number in a smaller sense. You guys did awesome today. Make sure you like this video. If you haven't, click that notification bell, hit subscribe, and I'll see you tomorrow.